Hello and welcome to my channel. My name is William. If you are new to this channel, kindly like and subscribe to get more content. In our previous video, we looked at introduction to GIS, where we looked at GIS, the various components of GIS, some platforms used to access GIS information, and others. Today we want to continue by looking at remote sensing. So today we want to look at remote sensing. What is remote sensing? Let's move straight. Now, remote sensing in the actual sense is a technique. So we say it's the process of collecting information about the Earth's surface. So just the process of collecting information about the Earth's surface. However, this technique is done without making physical contact. So with this type, you are not going to the site to pick, unlike going to the site to pick, let's say, coordinates, going to pick elevation, going to pick maybe rainfall data, going to pick soil data. All those, you are not doing it physical, but you are rather doing it remotely. So you are not there, but you are accessing information. So we can do this through number of ways, like satellites. Yes, you can access them. We have types of examples of satellites, and some of the satellites, we have the Landsat, we have the Sentinel, we have others, and the aircraft too. Yes, you can fly an aircraft and then access the information, and you can use drones. So those are some of the ways you can access. So wavelengths are normally we normally use the wavelength. So these data are accessed based on the wavelength. So we have the electromagnetic radiation. So it is based on the electromagnetic radiation. So it is normally done using sensors across various wavelengths. So we have the visible, we have the infrared, we have the microwave, you even have the radio waves. So you can use the EMR, that's the EMR, electromagnetic radiation. So we have either heat or light. So this data can be accessed. So as the light is being emitted on the earth, its reflection is being picked like camera. You see, when you are taking pictures, you only emit light onto the surface, and as it reflects, you capture the reflection using the camera again, so that you can get image. That is the same way the remote sensing also work. This time it's not camera, but it is rather satellite. So how is it being done? We have types. We have the passive and active. Let me explain it from here. So we have the passive remote sensing. The first one, I have passive remote sensing. With the passive remote sensing, what it does is it doesn't emit radiation. It only receives the radiation. So whereas others are emitting, passive doesn't emit. Normally it detects the natural energy. So its function is to detect the natural energy. So it is normally done using satellites. So what it does is, as the sun emits its energy, it falls on the earth. So its reflection is being picked by those satellites. So as it emits the energy onto the earth, its reflection is being picked by the satellite, and then it processes it for us to see those images. So the satellite is not having any camera up there that is taking pictures, photographs like they are seeing satellite image. Rather, it is just the reflection that is it captures to form those images. A typical example, let's look at this image over here, as this image is going to help us a lot. So we have the image over here. You have passive remote sensing. You see, here is the sun. The sun is going to emit the rays onto the earth. It is going to be reflected. As it is being reflected, the satellite captures it, so that it is going to capture the water body. So as the sun emits, it is being reflected, then the satellite captures it. That's how it is going to get the image That's how it's going to get the data on the water body. In the same way, if it is for this, let's say this hill, it emits over here. As it is being reflected, another satellite may be here, then the satellite is going to just pick it up like that. And so that is what it does. It doesn't emit its own radiation, it only receives. Whereas the active, on the other hand, it will emit its own. So this is the device, the, let's say the aircraft or the drone, or let's even say satellite. It is going to emit its own like a camera. Then it, as it reflects, it therefore picks it. So it is going to pick the reflection. So let's say it is being reflected, and as it is being reflected, the satellite picks the reflection of it and then gets the data it wants. So that is how active works. So it emits its own signal and measures the reflection. That is active remote sensing. So a typical example, you have the radar. So what the radar does is, if the radar normally uses microwave, which also belong to the electromagnetic radiation. So the radar uses microwave, and it normally measures elevation. So the digital elevation models we've been seeing, most of them you can do that with the radar. And we have the lidar simply means the light detection ranging. So the light detection and ranging. So light detection and ranging. So it will detect the light based on the it normally uses laser pulses based on infrared. So normally it is infrared. So it releases the radiation, or it emits it, then the reflection is being measured, and as it is measured, it gains the information it wants. So normally it's used to access topographical data, rainfall, forestry. Normally some of these let's say even monitoring, you can even use lidar for those as things. So example of even radar, we have the synthetic aperture radar. So you can normally access it using aircraft. You fix, and then aircraft you can use to cover a particular portion and then gains the reflection. One advantage the active remote sensing has over the passive remote sensing is the active remote sensing can work even at night and through clouds, but passive remote sensing, because it's normally relying on the energy from the sun at night, the energy is not able to be you are not able to measure the information at night. So if you want night data using those Landsats, it becomes difficult because you can't get it. You can't get night data because of how it works. Good. So let's look at the next one. Then we have platforms where we can get remote sensing data. You can access remote sensing data using satellite. Yes, like I earlier said, the Landsat Sentinel. It will measure the energy from the sun and then give you the necessary information you want. Drones can, they are normally active because it is going to emit its own radiation and then measure it to give you the information, whether NDVI. The NDVI is the normalized difference vegetation index. So the NDVI, you talk more about it in later videos. And then we have the aircraft. Like I said, you can fly it over a particular place. Let's say you want to measure the climatic change, you want to measure, let's say the rainfall, you want to measure particular type of data at a particular place, you can use the aircraft. And we have the ground based sensors. Those are at a particular place, but they have limited range, and what they do is, let's say earthquake, so you have the seismograph. Yes. Or you can have a seismological place center where it will be measuring the seismic waves. Yes, so it is ground-based sensor. It will be measuring the seismic waves within that particular area. So ground-based sensors. Also use some like the alarm sensors. Most of them are ground-based sensors. They are limited range. So then let's look at application of remote sensing. So in agriculture, it can be used to monitor crop health, like the NDVI I talked about. So when the let's say the drone is being flown over the vegetation, as it is being flown, it is emitting its own radiation and then measuring it. So it will be measuring different bands, different colors, like the red, green, blue, infrared. It will be measuring all those, and as it measures, since you are getting different kinds of wavelength being measured, you can clearly distinguish between the ones that are healthy and the ones that are not healthy based on the color. So that's why I call the normalized difference vegetation index. That's why it is an index. We have a way of working around it. Yes, maybe I'll talk more about it in later videos, the NDVI. And you can use it for environmental monitoring, like deforestation, water bodies. Yes, like the one we saw from the Landsat, how the satellite, how it is measuring the reflection from the water body. Yes, you can use to measure the erosion and other, like deforestation. Yes, and normally the deforestation works best using LiDAR. They are all remote sensing. And then we have disaster management, like I said, the earthquake, ground-based stations to measure the earthquake, the seismic waves, wildfires, floods. Yes, we can use remote sensing to gain those data as the sensors are in place. Urban planning, yes, application, good. So as this data is being picked, let's say we have been able to access earthquake data, we've been able to access we have been able to pick these flats. Now we can do proper land planning, we can do proper urban planning, where we know that these places are earthquake prone. So we know the kind of buildings these places are capable of flooding. You know the particular land use, the particular building. Should we use it for park? Should we use it for recreational area? Should we just make it commercial? So based on the disaster data, you can plan properly, and you can do climate studies and weather forecasting. Yes, using the radar, you have flown it, you've been able to pick the microwaves. You can clearly know the amount, the energy picked. You can interpret it to know the climate change and then predict the weather like the meteorologists do. You can do that, not going to the atmosphere to pick the water. No, you can set up your ground station and then measure it using the remote sensing technique. Now, remote sensing data type, we have the multispectra. When we say that multispectra, it has multiple spectrum. Like normally it has four: the red, green, blue, and then the infrared. So you can use the multispectra with different spectrum to access. And then we have the multispectrum image. So those images are the ones normally given by the satellite. And then we have the hyperspectrum. Those ones are normally accessed using the active remote sensing. So hyperspectrum has a lot of spectrum. See, multispectrum is limited. Hyperspectrum is also limited though, but it has a lot. Multispectrum is said about 4. Hyperspectrum has multiple colors that you can use, and that's how come you can work on the NDVI and the NDWI using the normalized difference water index. You can, and thermal imagery, yes, using, we can normally use that the thermal to access heat heat. Yes, so the heat can be able to predict the wildfires. Sometimes not being said by anything, but the heat that is being emitted, you can clearly see that it is going to cause wildfire. And so we normally use the radar, the thermal, like I said. And then we have the radar imagery, like I earlier said. We have the synthetic aperture radar. You can access that using the aircraft. And we have the LiDAR, the light, like I said, the light detection and ranging point clouds. All these are remote sensing data types that you can gain. What is next? In our next video, we are going to look at the remote sensing. And the remote sensing, what we are going to do is we are going to see how remote sensing and GIS complement each other. So we said remote sensing, we've talked about GIS. We are going to see how they are going to work together in our next tutorial. So enjoy the rest of your day and see you again in the next video. Make sure to like and subscribe to the channel to gain more updates. Until then, bye bye.